5 after. Good evening. I'm Gundars Oswald, the Program Director for the Incose chapter. We're having a co-meeting with the PMI Baltimore group. We have about half of the people here from PMI, and we welcome them. This evening, we're going to have an extra half an hour. Our meeting's going to run an hour and a half because we anticipate a lot of questions for Marvin. He's going to be the fall guy for all these questions. But anyway, the book is a collaboration between PMI, Incose, and other organizations. And Wally's also publishing the book and it's available on the Incose website and I think on the PMI website. So Marvin, let's see what you can tell us about the book.
Okay, well, I'm not going to tell you a lot about the book. To try and compress 400 pages of information into an hour won't happen. But I do want to talk to you about a few things. One, I want to start with just kind of what led to this work. So some of the early research that PMI and Incose teamed up to do. We'll look at that. And then we brought MIT into the mix, and then MIT led a number of follow-on research efforts, and all of that ultimately culminated in the book that published earlier this year. Now, having said that, and for those in the room who have pursued academics, you know how dry research writing can be. I'm guilty. I just so you know, my background is a perpetual student. I am now working on my doctorate. I just haven't had enough yet. So I understand that's a terminal degree. Once you get the doctorate, you terminate. That's what I hear. But anyway, I want to assure you the book is not written as a research book. All right? We took the research and then turned that in. What did the research tell us? And so I want to talk about the initial research, where that research led, and we'll spend a great deal of time on that, but we'll do that by taking a couple of case studies from the book and show how this exhibits itself. What does it look like when you have very, very tightly integrated program management and systems engineering on a program, all right? So that's where we're gonna go. Like I said, the book is structured roughly around these 4 main sections, all right? So we look at why is integration important to program outcomes? What is it that drove, again, the whole effort? what actions produce better integrated programs? I mean, if we show that it makes a difference, then we want to start understanding, well, what is it that we need to be doing to make that difference a reality? How do you improve integration then in programs and within the organizations that run them? And then lastly, who must act to make this happen? All right, so that's how the book is structured. It's 4 main sections. As I said, throughout there are illustrations, case studies, where we had a number of contributors help us with these. And they came from aerospace, from large infrastructure projects, information systems, other major programs. And ultimately, what we wanted the book to achieve is that we would be able to give the reader tools and guidance, specific things you can take back and begin to focus on within the organization to improve program outcomes. All right, that was ultimately what we were after. All right, having said that, how did this get started? Well, initially, PMI and Incose teamed up to do some research. And the outcome of that was that we determined that the current state is there is some systems engineering and program management integration happening within companies, but it is not fully integrated. And there is examples of routine failure in complex programs. And so there needs to be some work done. The vision was that we'd gain an understanding that all work is relevant to both groups, and that the delivery of the stakeholder value requires an appropriate contribution from both areas. So I come from the perspective of appreciating systems engineering, but being a program manager, all right? So understand that bias when I talk. My first year, or what I call my first attempt at college, I thought I wanted to be an engineer. I made the mistake of telling the dean of the engineering department at the outset that my ambition was to become a recording engineer because I'm a musician, to which he promptly replied, "That's not engineering," and sent me to a tech program. So I didn't pursue that, but I did pursue engineering subjects, pursued math, later on pursued physics, and did go into an engineering field in radio. But then quickly moved to the management side because I'm just not a good engineer, bottom line. So we want to understand and appreciate what those two pieces are, right? And what we found is that in our initial research, program management and systems engineering tend to operate in silos. They're very discipline focused, which makes sense because they've spent years developing their discipline. But they're very discipline focused within the silo. And there's little cross-integration and working together to achieve a common objective. And so what we proposed is that there is a better solution. And that's what the research set out to find then. So we began to conduct further research. In 2008, a study was done based on some GAO data from 2006. The key point here is that that research in the DoD specifically showed that typically costs exceeded budgets by close to $300 billion, not small money. That schedules tend to overrun by 22 months. And there were similar situations in other industries. All right, so this was not just unique to DoD. So that was the current state. So in that initial research, we asked a number of questions that led us to some observations. One is, most organizations somewhat integrate the two functions. Somewhat or mostly attempt to integrate the two functions. The majority find that the integration of the two roles to be somewhat effective. In other words, they may be trying, but they're not getting there, was the point that we took away from that. some unproductive tension is occurring between the two roles. And if you've worked on the program with the systems engineering and with the program manager, you've seen tension. There's value in tension, but it can also be unproductive. And that's that led us to go deeper into that subject area to explore that a little bit more and find out what that looks like. Found that there was a lack of planning for integration. In other words, a lack of intent focus on we have to integrate these two roles. They're not two separate paths that happen to converge at the end and give you an outcome. Those who perform both roles, this makes some sense, those who perform both roles, that is their chief systems engineer and program manager, tend to do better. And that would make sense. They understand the value in both roles and can bring those together. Systems engineers are more likely to say that there's unproductive tension. All right? Systems engineers are more likely than program managers to say there's unproductive tension. And systems engineers are more likely to attribute the tension to unclear expectations and lack of authority than the program managers. All right, so that was the initial result. So what we looked at then is how do they view their role? So if we're asking a good number of program managers and a good number of chief systems engineers, define your role. How do you see your role? And you see on the left here of this screen a number of characteristics that the program manager views as their responsibility. You know, they're responsible for the overall results. They're responsible for program and project risk. They're responsible for life cycle planning. And then the chief systems engineers would say, we're responsible for the technical requirements. We're responsible for the systems requirements. We do the configuration management, all right? So you already see these kind of silo concepts. You don't see them coming together. But both roles are responsible for the program or the project risk. Both functions are responsible for external supplier relations. Both functions were viewed to be responsible for quality management. And both functions have a role in life cycle planning. So the integration effort and where we're trying to go, it must clarify then how responsibility can be effectively shared across these disciplines, especially when we're looking at risk management, external suppliers, quality management, et cetera. And communications has to be optimized for the other domain's responsibility. So that's where we began, and so then we started to define terms. So what do we mean by integration? Well, you see on the slide a number of points that we have defined in our work. One, having a shared set of objectives. So it's not, I look at this and this, I'm to maximize this, and the other discipline's looking here and saying, my role is to maximize this. No. The integration says we both understand and have a shared set of objectives that we're trying to achieve. Everyone knows what those objectives are. So they're not kept within each discipline. Integration means that there's clarity and understanding around everyone's roles. Further, integration means that there's respect for the contribution of each of those roles to the program. And lastly, valuing and promoting collaboration over competition. So this is not about competing, it's about how do we collaborate to achieve the integration ultimately that leads to program success. So that's how we defined integration. As I mentioned, unproductive tension was another issue, and we saw in the research clearly that is a block to integration. So if there's unproductive tension, it's not helping integrate the two roles. And there we found that failing to communicate and establish this common set of objectives that we just talked about is part of integration, that would lead to unproductive tension because we don't have a shared objective. We don't have a shared vision of what we're trying to achieve. Individuals and groups focusing on achieving objectives defined by their discipline, but not necessarily the program's result. Being unable to work together to achieve globally superior outcomes. And unproductive tension results from not valuing the other's role and contribution, as I've already said. All right, so that was the initial research that we began. So we had some terms, we had some things that started to emerge from that. And so then we did follow-on research to begin to dive deeper and try and understand what's going on here. And we segmented two groups. We looked at program managers and chief systems engineers who were indicating that their programs are struggling, that they are failing in some way. And so we looked at those characteristics. And then we turned our attention to those who said that they are successfully executing their programs so that we could begin to understand, well, what's different between these two, right? That led on to further research, and that's where I'll cease the research discussion. But out of that, we began to put together all of these findings, and that produced this framework. And essentially, this framework can be summarized as 4 key dimensions, that being process, practices, and tools, organizational environment, people competencies, and contextual factors. Right? Those 4 dimensions, when properly done, drive effective integration. And if we've driven effective integration, and you see the 3 components there, then we saw improved program performance, right? So the basic model that came out of all the work is that we looked at these 4 dimensions and aspects of that, looked at what effective integration looks like, and then looked at how do we define program success. All right, so that's what this framework does. And the book spends most of its time exploring these. And what I want to do tonight with you is go in a little bit deeper in this central piece right here. We're going to talk about the effective integration. So these 3 components we'll zero in on a little bit more and discuss what that looks like. All right, so let's start with process, practices, and tools. So a few things that we saw directly enable integration or more effective integration. Clearly, communications is a key component. Being able to communicate between disciplines and having an open communications process. Defining specific work activities so that we know what's expected in that work package. Establishing expectations of each person's contribution, right? This is not just something assumed, this is something pursued. So we want to intentionally focus on establishing what those expectations are in the roles. Document the process then. Document the approach. Identify critical points where individuals and group work efforts must come together. Because there's no question there are points where we'll separate and go do some work activity. But let's talk about where those touch points are as the program moves forward so that we understand how they interact. Facilitating problem identification and resolution. So how do we surface those problems, and then once surfaced, how do we resolve them? Applying and updating best practices and supporting and improving specific work activities. Those are all pieces of the process, practices, and tools that go into that. And again, in that dimension, there's much more detail behind that, and we elaborate on, here are some practices that we observed. All right, so that's the process, practices, and tools. The next section that we said drives towards integration is the organizational environment. And here we're talking about the actual organizational structure itself. What are the behaviors characteristic of the organization? What's the culture of the organization. One of the key takeaways is that you can apply this framework and you can apply it well. But please understand, it's not a recipe and it's not a cookie cutter. Right? We spend time to say, okay, now we've explained and we've given examples of all these things, but you have to figure out what's the organizational context in which you're trying to do this work. How do you tailor this to fit those unique aspects? Further, there's a difference from one program to the next. Each program has its own unique characteristics. You have to, again, go back, tailor the process to that specific program requirement. So that's what organizational environment is trying to look at these aspects. How does the organization itself, how does the leadership set up and encourage integration to happen? Because culture can be a roadblock to that, or culture can be an enabler for it. All right, so that's what we're looking at when we talk about organizational environment. People competencies clearly deals with people's ability, right? So we already know that systems engineers know how to do systems engineering, and we know program managers know how to do program management, or should. What doesn't happen, and what we saw in those situations where program outcomes were more likely to be successes than failures, is that there was a concerted effort at bringing these two disciplines together to understand what the other contributes. And that was a key factor. So the training is not just training within your discipline, it's training as how that fits together with the other disciplines. All right, so that's part of the competency building. Staying current with where the standards are going in your discipline is important. It's also important to understand where the other discipline is going in terms of its development. Right? And then there's contextual factors. You know, and I've talked to this already a little bit, the program characteristics themselves, the team characteristics, how do the teams typically work together, and how can we change that dynamic? We've talked about the organizational structure, but that's not something you're likely to change, so how do we work within the structure? And then if it needs to change, how do we go about doing that over the long term? And then there's the shareholder or stakeholder, stakeholder alignment that needs to take place, because there are going to be various views, various points of interest regarding the program itself or components of that program. So how are we aligning those stakeholders' view? So the management approach, again, needs to be tailored to the program realities. Management needs to own the program culture. They set that pace, they set that tone. And the stakeholder alignment really does require one view of the program, or stated another way, one view of success. We have to have at the outset that shared objective, that shared vision of this is what we're trying to achieve and this is how we'll know we're successful. Often, programs get classified as success or failure based on three things: time, cost, quality, right? And those are important. But more important is, did it achieve the objective for which it was undertaken? And that's the benefit of program management, is that it gives you a view to what benefits are we trying to drive. So those four dimensions, as I said, build into effective integration. And that effective integration then really is a reflection of the organization's ability to combine program management and systems engineering. So it deals with those practices, tools, et cetera. It deals with those people. It deals with the organizational structure or organizational environment. And it has the other contextual factors that play into that. But when we get to effective integration, the three characteristics that we saw was that there's rapid and effective decision making, there's effective collaborative work going on, and there's effective information sharing between all parties involved in the program. All right? Really not rocket science. Most of us could have said this without going through all of the research, but now we validated it. So now we know we're right, right? On program performance, so you do see schedule, you do see budget, but client satisfaction is not just we think we delivered what we said we would, it's that the client says we delivered what we said we would. And that we, in fact, met all client requirements in the process. So cost and time certainly show better performance if we're adhering to the budget, to the schedule. That's a good sign. But the outcomes are more predictive with higher integration. That's the key factor here. That we can predict better outcomes based on the degree to which integration has been pursued. One of the interesting findings, though, is that programs that have this pressure on schedule tend to function more resiliently with integration. And again, that probably stands to reason because if we are all working for the same outcome, then those tensions that are going to develop when we have schedule pressures will tend to get resolved better because we're working together to say, what can we do? What do we need to do? Let's go get this thing done. All right? So that's the framework. And as I said, as I said, we're going to talk through that, but focus especially on the effective integration component tonight. And I want to do that by looking briefly at two case studies. One is the development of the Navy's F-18EF program, and the other one is a brief example from Royal Australian Navy Anzac frigate program. Right, so we'll look at both of those, and again, we're focusing on just the integration component itself, not the other factors, although those are called out, and I'll give you a couple of pieces of information from that at the end of each case. But I want to look at examples of how these two successes exhibited effective integration, and specifically in these three dimensions of effective integration. So let me talk about the case study just a little bit. In each of these cases, the actual approaches are different, but the outcomes were both good, right? So what that tells us is that, again, you can't just pick it up and drop in. You have to look at how do we use what we need, given the characteristics of the program we're trying to run. Right? And so you'll see that come out in both of these case study examples. So let me give you some background on the F-18. First of all, this is a dual-purpose carrier aircraft, right? So it has air-to-air and air-to-ground combat capability. The prime contractor on this case was McDonnell Douglas, but Northrop and GE both had significant contractor roles as major subcontractors to the program. It was an evolutionary design over the previous model, which was the CD, a very successful but aging aircraft. And so what happens is we see EF taking a whole new approach to how they're going to evolve that aircraft. So if this was a program, and programs are about realizing specific benefits, what were the benefits they were pursuing? Well, a sampling of that was this new aircraft had to have increased range. It had to have an improved survivability. It had to have greater carriage capability, i.e. weapon systems. It had to have the ability or capability to grow in the future. So it wasn't just for where it was designed at the point of deployment, that was it. It had to accommodate future growth. And then lastly, it had to improve its bring back. So those were the benefits that they were pursuing, right? So what was the setting? How did this come about? Well, first of all, preceding this was the cancellation of a major embarrassment for the Navy, and that was their A-12 program. They had spent in the billions and were getting nowhere, and eventually the program was just canceled. The Navy's reputation for acquisition management, as it says, was at a low point. This was a big black eye for the Navy. Super Hornet was critical for maintaining operational effectiveness in the field. And there was no question the Navy had to get this one right. So what does it mean, getting it right? What did that look like? Well, with the Super Hornet, there was a premium on open communications, decision-making based on objective data, and collaboration across functional disciplines. So the old way of working was a serial fashion, and if you've done government contract work, and I'm sure there are people here who have, you know the process, right? The old way was it starts here, it gets moved over to the next group, who bolts on all of their requirements to the process, and then it moves to the next group, who then bolts on their requirements. But oh, by the way, those other requirements that you put in their previous group, we can't work with. So it goes back to rework. Moves forward again. Oh, we can't work with that. Goes back for rework, right? I love Dyer's quote. I've used a form of this myself often. But Dyer said, you know, our situation going into this was that we were setting out to design a racehorse and ending up with a camel, right? Because everybody had a different focus on what they needed to do. Everybody had a different focus on what you optimize. And so I want my specialty optimized. And I'm not talking about disciplines, it goes further than that. I want my specialty optimized. Hey, there's some really cool new, I'm a geek, right? I'm a real technology nut. So there's some really cool new technology. We got to put that in. Why? Because it's really new and it's cool. We got to put that in, right? Well, that doesn't put the objective at the focal point. It's putting, what could we put in there that would really make this thing extra neat, right? So that was the process. That was the problem they were in. And they had to fix that situation. So how did they do it? Well, I have to say this did not come about at the outset with intentionality. It came at the outset because of the same results were starting to emerge from the beginning of the program, meaning that we had everybody developing their own little pieces of this major program, and it was getting huge, and nothing was going to work together, right? And so I believe it was after a full week or maybe 2 weeks of meetings where this was clearly not going to work that Dyer, who was the program manager for this initiative, Dyer and a few others killed the meeting. And they went back to their rooms with a handful of people and said, what are we really trying to do here? And they worked overnight to come up with a set of core objectives of what they were trying to achieve, and came back the next morning and changed the whole meeting and said, this is what we're going to achieve. One of the things that Dyer notes is that after they started implementing and better integrating the functions, one of the things that they quickly started to identify in the teams was the plane is the boss. Everything is about the plane, not about my particular discipline, not about my specialty. It's about the plane. So how did they do it? Well, they developed these things called integrated product teams. What was unique about these is that these teams were multidisciplinary. In fact, they broke new ground that had never been done before. They actually had a government side IPT, contractor side IPT, that worked and communicated collaboratively. Within the contractor IPTs, they worked contractor to contractor. They were allowed to work directly together. That was unique in a government program, especially in defense. So what they found was that, or what they established was that corresponding structures in this process facilitated joint problem solving and improved communications. So the IPT became the key aspect of how they integrated because it allowed open and direct communication, it allowed shared objectives, it allowed for rapid decision making based on factual data. So it produced a culture change. So the hallmark of the program was this effective collaboration that was starting to take place across, within and across the IPTs. It started to emerge, and again, this was something that they had hoped for at the outset, but had never tried before, and it clearly worked. So how did the program foster real teamwork between government and contractor personnel? Again, Dyer's quote here, "Leadership matters and personalities matter. The VP for the F-18 at McDonnell Douglas and I had an openness with one another that we knew we could build on. They actually had served together, which was a plus. We knew that we could flow it down to others and that we would both insist on it." So this goes back to setting that organizational culture, that program culture. Comes from the leadership. They were going to insist that it happen. There really is a culture change required, and we're not taught to be team players. That was his observation of the effort. So I said the other piece here is rapid and effective decision making. Well, you can see in the IPT breakdown, this followed the work breakdown structure, so that you had the top level weapons system, and then you see how that flows down to a level 5. The key there is that they were pushing decisions down to the lowest level. So if there were issues that exhibited themselves, it didn't get pushed up to the top to resolve. They pushed it down to the layer that could best solve the problem. Generally, we find that that's the people closest to the problem. They have the tools, they just need to be enabled to solve the problem. And so that's what this did. It pushed it down that 5-level structure to say, if you can solve this issue at level 5, solve it there. We don't want it being escalated up. If something materializes at level 5 that impacts level 4, absolutely you push it up, right? But it's not to hand it off for somebody else to solve, it's to hand it off so they're aware of what problem needs to be solved in this case. So, as I said, team leaders have to balance cost, quality, and schedule. They have to be good business folks as well as engineers. As a level 5 team leader, this was from quote from one of the team leads, "I'm running my own business." Well, that's a different mindset. That's a whole new mindset. So the WBS and corresponding organizational structure was used to track cost, schedule, technical performance, et cetera. And that same structure, as I said, was used on the government side and had an equal or equivalent on the contractor side. So in rapid and effective decision making, 3 things started to emerge here. Identify problems early. Don't shoot the messenger. Just because somebody brings the problem to view, they are not the problem. It's the issue that needs to be solved. And management has to support solving the issue. The outcome is you're not punishing for bad news, but one of the things that they noted, Dyer and others in this case study, was that there were consequences for withholding information. So if you weren't openly sharing, there were consequences. But if you shared that an issue came to light, absolutely encouraged. In the book, there was a section they talk about, they had a new team member, a member new to the team, hadn't experienced this new culture, right? And so they came into, I believe it was an IPT meeting at the time. And they walked into the meeting, and the first words out of their mouth was something to the effect of, there's a problem with the contractor. And Dyer said, you could have heard a pin drop. Those were not acceptable words in that room. Then they had to learn very quickly, no, you have a problem because you have something that's not working at the contractor level. It's your problem, own the problem, and go resolve it, right? Again, a whole new mindset, but that's what it takes to get to effective integration. Also, we said there has to be effective information sharing. Example of this, well, before I get to the example, let me talk about this just a minute. They placed a high value, as I said, on this open communication. There weren't silent problems. You were expected to bring anything that you saw emerging to the table quickly so that it could be dealt with. They had a common central database, and they allowed access by others into that who were on the program. So everybody had the same view of the program, not disparate pieces of the program. And a variety of program-wide tools and databases, and that's not so much important what those were as it's an example of how you build up an open and collaborative platform where everybody has access to the same information. Again, the book, the case study talks about, you could have the contractor on the phone and the IPT lead on the phone talking about an issue, and they were both looking at the same set of data. So there wasn't this translation across the transit, right? So an example of this was, so the Super Hornet has 2 GE engines. During a flight test, and I don't understand quite all the technical details here, so forgive me on this one, but I get the outcome. During a flight test, a stationary airfoil fractured, causing significant damage to the engine. Well, that's why you test. You want these things to exhibit while you're testing, right? That grounded that plane, but then it immediately raised the question, is this unique to this one engine, this one aircraft, or might we have a problem across all the engines and all the test aircraft, and the other ones just haven't exhibited it yet? So bottom line is what they did is they tore down this engine, found the issue, and they immediately went to every other test aircraft and opened the engines and found that, yes, indeed, there was a cycle fatigue failure occurring. It just hadn't happened yet. Under normal circumstances and the way programs had run in the past, this is obviously GE's problem, right? Because they made the engine, so they need to solve it. It would have been 6 months before they were able to resolve and get a plane back up. They actually solved this in 6 weeks. Everybody converged on that, and GE was able to draw on the expertise of others who weren't on that team, but had seen experiences that allowed them to bring that experience to bear on this problem. They solved that and had those engines back up and running and back into test mode in 6 weeks. That was unheard of. Again, why? Because they effectively integrated. They were communicating, they had a shared objective, everybody was working for the same goal. So, we look at that case summary, we see that first of all, there's a whole lot more detail. It's a fascinating read. It's a whole chapter in the book, and it still leaves you wanting to know more. But there's a lot more detail there. But the key is senior leadership, both from the government side and the contractor side, were key contributors to casting the vision and establishing the process by which that vision was supported. And secondly, aircraft development is all about trade-offs. I mean, you know, in the whole engineering discipline, you can optimize on one aspect. You can't optimize everything. That just doesn't work, right? But in this case, there are trade-offs. You're going to have to look at cost, schedule, and technical capability, and that's going to need to involve program management and systems engineering working together, right? So I said that's a focus just from that example on effective integration, but there are others from these integrated practices pieces that I talked about earlier that show up. I'm not going to go through all of these. I just want you to know that there are other pieces that are called out, some things that you can observe in that case study that support the integration of process, practices, and tools that support the aspects of organization environment, that supports the people competencies component, and that supports contextual factors, right? So there's a whole long list, and you can come back and review this later with the slides, just to read through that. But I wanted to show you that there was much more than just the piece that we're looking at. We analyzed a whole bunch more. Secondly, let me talk just briefly about the Australian Navy program. So basically what this was about was re-equipping the Anzac-class frigates with a new electronic support systems, basically to gather data. So they're going to look at electromagnetic radiation and determine are they about to be or are they under assault? How do you differentiate between friendly and unfriendly information? So they had to go back and re-equip all of their frigates with this new technology, which included work from 4 primary contractors on the actual systems, but an additional 3 contractors who were working on components such as the antenna systems that had to interconnect and work together, right? So very much a systems engineering challenge. How do we pull all of this together and make sure it all works? But the bottom line is that they had to work closely together, right? So we won't go into their particular organizational structure, but there are 2 components that had to play into this, that had to be constantly communicating, sharing the information, and again, have a common objective. So the way the program started to roll out, there was a full 2-year period between the selection of the system and the actual funding to start the deployment of the systems. Well, they didn't sit and wait for the funding. They started once they knew that that was the road that they were going to go down. So both project manager and the chief systems engineer had engineering backgrounds. That was a plus. They understood each other's discipline well. They obtained funding to support a series of risk reduction workshops over that 2-year period. So they started early to identifying what are the potential risks and how can we mitigate or minimize the potential of those risks turning into issues. And then in 2013, the ES upgrade project actually obtained full funding. So they were able then to move forward with the process, right? So here's a bit of how that starts to work out. The ship upgrades are limited to specific windows, right? So they're going to bring a ship in for retrofit for a number of other things that have to be done, and when they bring it in, they're actually cutting a hole in the hull to be able to move equipment in and out. They're pulling ceiling down so they access everything. Because they had done this pre-planning and had thought about what's the objective here, they were able to harden the requirements for the fixed hardware assets. So they knew the antenna systems, they knew the cabling that had to go in. And so when that ship came into dry dock, they were ready to actually pre-install the stuff that needed to go into the infrastructure of the ship. Later, they could add in the electronics system. So they actually built the program around that opportunity. So the cabling, masts, foundations for the equipment racks, multifunction console, all of that went in while the ship was in dry dock. The strategy saved them having to then reopen those ship components at a later time. All right, so now we've sped up the process. The ship was already coming in for other work. Let's use that time. They called this fitted for but not with strategy. So every ship was actually being prepped for the installation once they were ready to roll, but the actual electronics were still in development. They were still in testing, and it hadn't gone into field testing yet. So let me move on here with the context. It sounds simple. It wasn't that easy. They had to, again, establish what are the core program benefits that we're trying to achieve, and how do we work together to get those done? And then what can we do to minimize risks in actually being successful with this program? So that was all done up front. The way this plays out, one talked about use the work reduction workshop. Use that time to actually start defining what work and where we might run into problems. So that was effective collaboration. It was key, and this came out a bit more in the case study, that they had to work constructively and collaboratively. This would have been very easy when they encountered things that did not quite go as planned. It's very easy to just point the finger at, it's your problem, or to end up with this interface, right? So the problem is on the other side. But they avoided that because they were actually in a teaming environment. Again, the contractors were working together with the ship as the common objective. In addition to the work reduction or the risk reduction workshops, information was shared again via computer system, and so they had simulations that they could run, and everybody could participate in that process. So they were able to test the interfaces before they actually deployed the electronics. That was a key. To get to where did this end up? They have obviously prioritized the sequence of ships that they expected to install systems on, right? So they had one that was due to come in to be retrofitted with this new system. Problem was that turns out that ship was 6 months delayed. So there was a holdup in that ship. So decision had to be made. Does that mean we just hold for 6 months? No, because they had done this fitted for but not with strategy, they were able to shift the whole team to a new schedule, to a new priority, and went to another ship that was available that they could quickly install the electronics and begin testing. Right? So they showed flexibility in the program, and everybody turned their attention to what's our current opportunity, and let's leverage that. All right? Again, that would not have happened if all of the team members were working in their own little silo. But because they collaborated effectively across boundaries, they were able to quickly change, adapt to the situation, and move forward with a very successful outcome that commissioned this to be deployed across all the frigates and was actually deployed in record time. Right, so that was the bottom line. Again, I'm focusing on the effective collaboration piece or effective integration piece. But there were other characteristics that we saw in these 4 drivers that came out in that case study. So that's just a quick snapshot of one piece of that framework that leads to effective integration. What I want to stress is this cannot happen unless everybody gets on board to make it happen. You can't look to the other side. I can't say, the issue is not me as the program manager, it's you as the systems engineer. You systems engineers got to come on board with us. It can't be that way. It also can't be, I am just running my program, I get my orders from above. If you want to effectively integrate and see improved program results, I'll leave you with this. It starts with you. You can make a difference. One of the case studies that we looked at is something that actually happened inside Nationwide in software development. They had a unit that was outperforming everybody else in success. And smartly, Nationwide management said, why is that? And they found out because it was effective integration of program management and systems engineering. And so management came on and said, this is a good thing. What do we need to do to get this across the whole organization? So you as an individual can make that difference. You can start the movement and get everybody on board. Question?
Okay, I'll start off with the first question.
Oh, you got to wait.
You gotta
Gundar's
wait.
got the mic. He owns it.
Yeah. You know, I've worked as a system engineer and engineer for many years, and our job was perfection. And on the other
Okay.
side, the program managers and the program person said, well, we got to ship. So how do we, you know, with this new process, who gives in and who, and at what point, you know, how do we negotiate that?
Okay, so the first point and the first word I would say, got to get rid of. Right? So who gives in?
Right.
Nobody gives in. Right? Because if you go on with that mindset, it's a win-lose situation.
Right.
So it's more about what do I need to change in order to get there. And so I'm a perfectionist by wiring too, and I'm on the program management side.
Right.
So I don't know that that's the real issue. I think what it comes to and what your question is driving to is, what do we really want to achieve?
Right, and I think part of that would be we need to understand the customer's needs. From everyone in the program needs to understand them so they can satisfy the customer, not necessarily be left into wondering what did the customer really want.
True enough. Yeah, any program that starts out without solid outcome requirements or benefits, what are we trying to achieve, is doomed to achieve something, but it may not be the right something.
Right.
So.
Okay.
Harry Windsor, how do you apply this integration paradigm to political entities like legislatures and where public has a right of comment and so on, and where things get very divisive?
Yeah, and some things are just hard to change. It was interesting, one of the cases that threads its way through the whole book was something that you're all familiar with, even if you've never experienced it, because everybody heard about the Boston Big Dig. And the question is, was the Big Dig a success or a failure? Right? It was way over budget. It took way longer than they thought it would. Part of that is due to the way, your point, to the way government works. If I came to you as John Q. Public and said, this effort, this program to build this new all-underground interstate freeway system through Boston is going to take 25 years and I forget how many billions of dollars ultimately, you'd never approve it. And so they broke it down. They started, with an unrealistic forecast. Not necessarily intentionally, but that's where the pressure is, right? So the question is, at the time it was going on, the public sentiment went really, really south. The support from government was going south. But they stayed the course because they had an actual program objective to achieve, and they kept their focus on that part of it. And I dare say now, if you ask the public, they would say, oh yeah, that's a success. What we're seeing as the results was what they actually started driving to. We're seeing communities that were in sad condition revitalizing because the roadway's gone and now they have green space. They've got new businesses moving in. The economy is responding, has been responding to that change, right? So in retrospect, they stayed focused on what they were trying to achieve and got it, but that doesn't quite answer your question. What do you do given the realities of working with government appropriations?
With the actual example facing us of reconstituting the energy system of the world, it seems to me that this is the key system change that's going to have to be used to propagate collaborative development into the whole world. And how is that going to be accomplished?
Honestly, I don't know. I don't know. From a program management side, I would say you begin to look at what are the benefits? You have to sell those benefits. And you have to stay focused on achieving those benefits. Cotter would tell you if you're going to affect a big change, you're going to do that with emphasis on a lot of small incremental changes that you keep pointing to, right? You have to have small successes that will ultimately lead you to the big success. And that's about as much as I can answer that.
Hi, this is Lisa. I'm curious about the research results. Was there any focus on looking at program managers having an understanding or experience in the work that they were managing? And on the other side, the system engineers having experience in managing work? Because in my experience, when you understand the work that you manage, you're a better manager. And when you understand that you have to be managed, you can't just go off the road, right?
Right.
There's an understanding of either side. So I think it plays a factor because there's been times where I have seen program managers that are very good, incapable of managing the project because they simply don't understand the work that's being performed. I've never written code, they've never designed a system, the gambit of things. So I'm just curious whether the results had any effect in that area.
Yeah. And that was a key piece that was investigated and found to be true, right? So I don't need to be an experienced systems engineer, but I need to understand what systems engineers do and the value that they bring. I was a panelist about 6 months ago in DC. The point was there was somebody else on the panel that was talking about his experience as a program manager. And he said, when I get that first invite to the first meeting at the very, very point where we're starting to think about a program, so they're bringing the program manager in to start discussing the program, he said, I never go into that program without my systems engineer. Why? Because I need that input. I need that vision for what's the systems. How is this going to evolve and how does it all fit together, right? So that is something that you can train, and that's what we point out in the book. So to become intentional about setting up training programs, not to just keep developing you in your discipline, although that's important, but to develop you in the other discipline so that you have an appreciation for what that discipline brings to the table. That we did find positive correlation very strongly in the research.
My name is Mandy. I have a question concerning the methodology. So a lot of the case studies you pointed out seem to be some maybe older, maybe waterfall. What we're dealing with is the integration of program management with system engineering and agile development. Is there any research in that area? I am both a program manager and a system engineer, so I'm technical and program management, so I don't know what I want to do when I grow up, basically. So have you done any research in that area applying this integration? Because I see this as much more, integration much more important now in the agile methodology than even in the previous.
Yeah, and that was not specifically called out in this work. There is some ongoing work that's being done from an agile standpoint. But let me get on my soapbox for a minute. When we were in the final stages of the book, I would have people ask, well, what is it about? And I try to explain how we're integrating and looking at how these two disciplines work together in program management. And this very bright doctor looked at me and said, oh, so it's like agile. And I go, okay. Excuse me, but program management, by its very definition, is an agile approach to managing, because the program sets its sights on benefits and adapts and changes projects and sub-programs under that to achieve the benefit. It has to be agile. Now, is it an agile methodology? No, but it has to be agile. I venture to guess that the same is true on systems engineering side. I have a quote that's up on my wall, and I won't get this quite right, but I've had it in my cubicle for a while at work, that basically says engineering is about working with materials we don't quite understand in ways that we can't predict, and it goes on, and fooling the, and the public thinking we know what we're doing, right? So that really captures it, because if anything about engineering, we're trying to do something new, right? So do we understand it yet? No, we're learning as we go. Is that agile? Yes. So it doesn't quite answer the question, because I think there's another dynamic. How do you do things like work breakdown structure and then put that into an agile approach to actually developing that component? I don't know. But I do know that the program management function should be able then to work with that, because it's constantly looking at, is it moving us to our benefits? Is it getting us what we need? Sorry, I know I didn't quite answer the question.
Let me put a plug in for the next meeting. We actually have the Department of Transportation from Maryland talking about how they're going to run their system in an agile way, because they got to get things done quickly. So that should be interesting. Plus, we've had 2 or 3 other talks in agile that you should be able to see on the video. So go ahead.
Okay, I had a quick question. During the FA18 example, the term IPT stuck out at me, because we were going through software SEI, CMM levels, and you got the 2 and 3, they definitely stressed IPTs. So is that where that, maybe the genesis of that became, out of that software, because they finally became CMMI, and it was right around that time frame. So I'm just wondering if that might have been an impetus for getting, IPTs more strongly enveloped in the program, do you know?
I have no idea.
So in your research, they didn't tell you?
No, that did not come out. I was going to come back. Oh, not to sell the book, but when you look at the nationwide, and pick up a copy while we're here, you can look at mine. Nationwide insurance, I mentioned that just briefly, that they had this team within it that was out producing everybody else, or maybe I just said it was software development, but it was the IT department within Nationwide, right? But I bring that up because part of what they were doing was early agile. So you may get some insight there into kind of what their experience was.
Yeah, I have a couple of questions. Well, one statement on ANZAC, you said you know, fitted for and not with strategy. So was one of the big drawbacks there propagation of error if they didn't take into things account that they were not aware of? You know, and that would propagate to a whole bunch of individual platforms, and then that would cost a lot more. You know,
Correct.
design in, don't design on. And the other thing was relative to the IPTs. You have to worry about requirements, traceability, and at the beginning, and also talking to the ops people in case there are unknowns. That's happened, you know, one of the upgrades of the E2D. No, yeah, don't radiate in an unsafe direction on carrier deck because they had a totally different architecture and no dummy loads and RF switches. And it took them a while to figure that out, even though they got a huge number of aircraft when they, everything was complete, you know, a lot of production. So do you take into account too, early on, you know, when we're going back to upgrades, all the supportability areas have to be integrated, you know, and talked about in the IPTs.
Right. Yeah, so let me start with the ANZAC case. I think it's key to keep in mind two things that they did that allowed them to deploy the fit for or fit before or whatever that was. One was they used that 2-year window between when they said that they are going to deploy and when the full funding came on board. They were actually able to pull funding in to say, we want to start now. And in that risk reduction, they had all 7 contractors working together. So that allowed them to do the pre-risk mitigation work that you spoke of. Plus they could do then the simulations across that, right? So they could build that out before they actually built it in. So they understood the infrastructure level before they deployed the electronics onto it. That's my understanding of that case. On the F-18, I don't want to imply that there weren't changes along the way. There were. There were a lot of changes along the way. But they were never done in isolation. So one of the things that they noted in the post-mortem on that initiative was that there was a 50% reduction in redraws. Right, and why? Because they talked through, there were no surprises for the other teams. So the way they achieved it is not that they didn't run into issues, they absolutely ran into issues. But it was always solved collaboratively, never a case where you own the problem, you fix it. It's we own the problem, how do we fix it? Does that answer a bit? Okay.
Well, thanks. Real quick, would it be possible, you know, in future presentations to have the slide number visible on the bottom right, so people have questions and they take notes, you can go right back to that slide.
That would help me answer it too.
Yeah, because we had a presentation by a prof at Virginia Tech about 03 or sometime, and he talked about presentations. You know, he was a nuclear engineer, et cetera, you know, summer of 03 or sometime.
Yeah, got it. No other questions?
You guys are too quiet.
I could ask you more questions about the agile process, because I know that because this book was written just recently, but it's been studied over the last 10 years, right?
No, actually, work got underway 2010, 2011.
Right.
So the
that's-
initial research was
Right.
was a 2011.
And that's when Agile was started up and has gotten a little bit more serious over those years. And so, so probably another relook at the concepts would be interesting to see.
Yeah, like I said, there's follow-on work that we're doing right now, and this is not as part of the Incose Alliance, but there is some follow-on work that we're doing in Agile. I think the key is there are going to be specific interests from the Agile approach, from whatever flavor of that you're using. But don't let it get in the way of what the key message of this book is.
Right.
Right? So it doesn't matter what the approach is as much as it's important that you deploy those things that we show in the framework.
Well, basically, Agile could take those pieces and chop them up in little pieces and then run them through their Agile mill, the details that you have in that book, right?
Yes, yes.
So it's really it's a process.
It's not that they would chop them up into little pieces, but because of the way sprints run,
right.
it doesn't take away anything that's in the book. It just
Right.
says, again, look at the characteristics of the program, and if you've got a project that's running with an Agile approach, then you're going to tailor what you're doing. But it doesn't stop the collaboration. It doesn't stop the integration of disciplines. It doesn't change any of those core capabilities or attributes.
No, the collaboration actually happens more often with Agile because you're going through all the spins and so on.
I'm not an expert on Agile, so I want to be
Right.
very careful how far I dig a hole. Question over there.
Real quick, I want to make sure I didn't miss something. Very early on in the presentation, when you were talking about the research, you mentioned that you had two groups. Were the two groups consisting of practitioners from both disciplines, or were they one group, the practitioners from the program management, and the others from systems engineering? Could you touch on that real quick?
Yeah, well, and let me see if this answers it. If it doesn't, ask me more, all right? So we went out. The first thing you do in the initial research is identify your sample, right? So Incose did that on their side. We did that with the PMI data, looking for specifically those who we meet the criteria of program manager or chief systems engineer. So, and it was so specific that we threw out, if you were just systems engineer, we pulled that data out. We were looking initially at chief systems engineer because we wanted to get the person who's responsible for the engineering and the person responsible for the program and test the initial data there. So that's, it was pulling the sample from two databases, Incose members and PMI members. That then was put together into one sample, and we then sorted the data based on if they self-identified as a CSE or did they self-identify as a program manager. Does that make sense? Answer your question? Okay. And that was just the initial. Beyond that, then we broadened the terminology but narrowed the focus. So we did go into equivalent of focus groups for the next phase of work. And then later there's some data, there's some modeling stuff that supports that's the framework, that in fact tests to be true.
All right.
I think we've got all the questions out of them.
Yep, and we're a couple of minutes early too. So thank you, Marvin, for helping
Thank you.
us out.
Thank you very much.
And everybody stand by for a few minutes. We're going to draw and get a book out.